You have probably watched a traffic light change thousands of times without really thinking about it. Red means stop, green means go, and yellow means something like be careful. Most people assume those colors were chosen because they feel naturally right, as if red is inherently a stop color and green is inherently a go color. But that assumption is incomplete, because the real reason is less about emotion and more about visibility, engineering practicality, and the limits of human perception. Why are these three colors the standard in so many countries? How did they become a shared convention instead of a random local choice? And why is yellow in the middle at all? In the next few minutes, this will become straightforward, because the logic is mostly about making signals easy to see, hard to confuse, and quick to interpret. The common misconception is that traffic light colors are mainly psychological, like red feels urgent, and green feels safe. Psychology plays a small role, but the stronger reason is physical. Different colors of light travel differently through the atmosphere, and the human eye detects some colors more reliably than others, especially at distance, in rain, fog, or glare. Red light has a longer wavelength than green or blue, and longer wavelengths scatter less in air and haze. That means a red signal can remain recognizable from farther away in messy conditions. In an early era of railways and street signaling, long-distance visibility was a serious requirement, and red already had a history as a warning color in rail systems and maritime signaling. Green, on the other hand, is very easy for the human eye to detect at moderate brightness, and it can be clearly distinguished from red when the lights are designed well. Yellow sits between them as a transition color that is bright, attention-catching, and visible in daylight, which matters because yellow light stimulates the eye strongly for its brightness. The system also exists because a signal has to do more than communicate a rule. It has to do it quickly, with minimal reading, for people moving at speed. A driver cannot pause to interpret a symbol the way someone might read a sign. The signal must be processed almost automatically. So the design goal becomes, choose a small set of colors that remain distinct under many lighting conditions, can be produced reliably by technology, and can be understood with almost no thinking. Red, yellow, and green meet these requirements better than most alternatives. Once you see that, yellow becomes easier to understand. Many people think yellow means slow down or speed up, depending on what they were taught or what they observe people doing. But the core purpose of yellow is not to advise a speed choice. It is to create a predictable changeover interval, so that a driver who is too close to stop comfortably is not suddenly trapped by an immediate red. Yellow is a time buffer. It tells you the signal is ending, and it standardizes the moment when drivers shift from proceed to prepare to stop. The details differ by country and road type, but the underlying mechanism is the same. Yellow reduces uncertainty, and uncertainty is what causes sudden braking, rear-end collisions, and risky late entries into an intersection. A useful way to understand it is to follow the cause, process, and result. The cause is that intersections are conflict points. Different streams of traffic want the same space. The process is that the traffic light creates turns, or phases, where one stream gets right of way while others wait. The result is an orderly crossing pattern that reduces collisions and increases throughput. But phases must switch, and switching creates a dangerous moment because vehicles are still moving. Yellow exists precisely to manage that moment. It does not mean do what you want. It means the right of way is about to end. There is another misconception worth clearing up early. Some people assume the color order is fixed because of tradition alone. Tradition matters, but standardization is also an engineering solution. If every city used different colors, drivers would need to relearn the code when traveling, which would increase mistakes. Once a large network of roads exists, shared conventions become a kind of safety technology. That is why the same three-color system appears in many countries, even if the exact timing and rules vary. There are also design details that quietly support the system. The vertical arrangement of red above green is not random. It reduces confusion when lights are stacked and viewed from a distance. If something goes wrong with one lamp, or if sun glare washes out a lens, the position still provides a clue. This is especially relevant for drivers with color vision deficiency. A common edge case is red-green color blindness, where red and green can be difficult to distinguish in certain lighting. Position, brightness differences, and lens design become backups. Some places also use different shapes or additional markings, but the simplest redundancy is consistent placement. Modern LED technology made colors easier to control, but the basic idea came earlier, when colored lenses and incandescent bulbs had limitations. Signals needed to be bright, stable, and clear without being blinding. Red and green were practical, because filters and lenses could create them reliably. Yellow, often implemented as amber, was practical, because it remained bright, even with filtering, and it stood out well against daylight. So what looks like a purely meaning-based choice is also a hardware-based choice. If you look at everyday examples, you can see how this logic repeats. On electronics, red often marks power or warning states, and green marks normal operation. On industrial machines, amber lights often mean attention or transition. The traffic light did not invent this. It is one of the most widespread and disciplined versions of a general signaling principle. Limited colors, high contrast, consistent meaning, and a built-in transition. Still, the system is not perfect, and it has exceptions. Some intersections use flashing yellow to mean proceed with caution when cross-traffic has a stop control. Some use flashing red like a stop sign. Pedestrian signals use symbols instead of colors alone, because pedestrians may be farther from the signal head, and the symbols reduce ambiguity. Some transit systems use additional white or lunar signals for specific vehicle types. These variations do not replace red, yellow, and green. They add layers on top of a stable base. So the calm, simple summary is this. Traffic lights use red, yellow, and green because those colors are reliably visible, easy to distinguish, and practical to produce, and because a three-step system can safely manage the moment when right-of-way changes. Red is chosen for strong, long-distance recognition and established warning use. Green is chosen for clear, go visibility. Yellow exists mainly as a predictable transition interval that reduces uncertainty and conflict. Understanding this matters in everyday life because it reframes what the yellow light is for. It is not a suggestion to rush, and it is not merely a warning to brake hard. It is a designed time window that helps everyone share the intersection more safely. When you treat the signal as a communication system with engineering goals, rather than as a set of moods painted in color, the rules feel more coherent, and driving decisions feel less confusing.